we left off in this problem, we were trying to solve for lambda. So we have this ratio over here, so we say 19 times 4 lambda squared is 76 lambda squared equals 38. So when we divide 76 by both sides, we get lambda squared equals 1/2. And finally, we can get lambda equals the square root of 2 over 2. So now we figured out that lambda equals square root of 2 over 2. Now if you remember from part 1 of our video, we solved for x, y, and z in the simultaneous equations, and we found out what each one equaled. We found out that x is equivalent to 1 over lambda, and we found that y is equivalent to 3 over 2 lambda, and we found that z equals, so this is too high. We find out that z equals 5 over 2 lambda. So now since we know that lambda is equivalent to the square root of 2 over 2, to solve for x, y, and z, all we have to do now is plug in lambda for each one of these values. So when we plug in square root of 2 over 2 for x, we find out that x equals 2 over the square root of 2. So when we solve for y for lambda, so we have 3 over 2 lambda, so first of all, 2 times 2z cancel out. This is going to be equals square root of 2 over 3. So we have z over here. Now if we solve for z, we're going to get, I'm sorry, I messed up over here. Okay, so we have 3 over 2 lambda. So this is just going to be 3 over square root of 2, right? And this is just going to be 5 over square root of 2. So we solve for our x and our y and our z. So we figured out that it's going to maximize on these points when x is equivalent to 2 over square root of 2, when y is 3 over square root of 2, and when z equals 5 over square root of 2. So it maximizes on these coordinates, and if you want to figure out the actual quantity it gives you, all you have to do is plug this back into your original function. So we have, this is our original function over here, right? So we have, we have 2 square root of 2 plus 3 square root of 2 plus 5 square root of 2. Now whatever value that gives you, that'll be our answer. So pretty much once you get to this point where you actually figure out what your x, y, and z values are, all you have to do is plug that back into your original function, or what you're trying to maximize or minimize. So that's it, guys. See you guys next time.